All right. So obviously we can't just have the safe door falling in here. This needs to be mounted on the hinge that I modeled in there. So let's make a hinge constraint. Now a hinge constraint doesn't really exist, such as it is. We will use the cone twist constraint to more or less, well, not more or less, we'll literally make a hinge constraint from that. So coming back up to the pieces area here, I want to make the hinge be centered on where the hinge is. So as a convenience, I'm going to say, let's select the top and bottom hinge components here and just press delete. Say delete non-selected. Well, it looks like we got a little more than we wanted. So I'm going to click this again. I'm going to control click this to unselect that. And there we go. So now we have both of these hinges. I'm going to move this split back up to the pieces area because I still want that to behave the way it was before. But now over here, I have this. So I'm going to say ISO hinges. I'm going to, again, make an add, which, again, ironically, I will use to delete that. And you can see these two dots are still there. Delete geometry will keep the points. But we'll group them here, meaning make a line again. So that line now exists, as you can see here, through the whole hinge area. Cool. The problem is, and there's always a problem, is I don't actually want to spin the hinges per se. I want the constraint to deal with the main chunk of the door versus the main body of the safe. So I'm going to make another one of these things, copy and paste, and I'll say select the outer door here, or the outer safe, and then the inner safe. And then we'll take a look at that. So now it's just these two pieces that you can see too. So once again, I'll look at here, and I'll bring up this guy here, safe 21 and 23. I want to actually attribute copy over. These are the names that I actually want, safe 5 and 20. So I'm just going to say copy them to this. So now I'll just put name here, and now we have the position of these. Like these positions were not that useful, where it's like the center of this giant box and the center of this. I want the hinge to actually be where the hinge is, but it has to have the names of the two pieces that are being rotated. So that's just one way of doing that. As you've seen in the previous lessons with the hard constraints, is the hard constraint kind of stuff, including the cone twists, work much better when they don't have any actual length, at least when they're working in the all mode, which we'll review in a moment. But in any case, for now, all we want to do is drop a primitive stop down here and just scale it to 0. You can see because it's pivoting around the center of it, the centroid X, Y, and Z, it's collapsing it from that long line down into this one point. And like our glue constraints thing over here, let's drop down a primitive wrangler and say you are a hinge. So we'll say constraint name is hinge. We'll call it cone hinge. That way we know what kind of constraint it actually is and give it a name like hinge. Because later we'll have cones for our actual links itself. And we'll say constraint type. Now this is just like with the hard constraint in lesson 3. We want to have that be all. By default, it's just position. It will only constrain the position. We want to constrain the rotation as well. Actually, it's mostly rotation that we're interested in. So we have, it's hinge and all. So we'll say hinge properties, well, hinge constraint, and we'll merge that into our constraint pile. So it reads it all in at once. Great. So we got that. Some reason I put a 0 there. Now let's go back into this and say, okay, well, we still have our glue, but we never actually ended up making a cone twist. So let's do that. Cone twist constraint relationship. Merge. And we'll call this one cone hinge. And the thing where you actually need to write cone hinge is down here at data name, cone hinge. And there it is. So it showed up. So let's see, what does that look like? All right, well, that's something. It's hanging off now. So that's an improvement of some sort. So let's figure out, we need to set up a whole bunch of these things here in terms of the rotations that it's allowed to do and all this twisting and all that stuff. But it's hard to tell what it should be doing without actually having some motion to move along it. So let's jump right to that, and then we can refine this once it is actually moving. And I don't mean just sliding down. I mean, let's give it the actual door opening movement.